Now we want to talk about angle measure in polygons. So first of all, remember just some terminology. When we talk about a convex polygon, it's one like this one right here, where if you extend any side, notice if I go through here and extend any side, it doesn't pass through the interior of the polygon. That means that this polygon is convex. In contrast, this other one is concave. Notice if I extend this side, it passes through, the side passes through the interior of the polygon. So this one would be concave. This one over here is convex. Okay, so just that term is going to be used, so we need to be sure we're familiar with it. Now, what we want to do is we want to figure out a way to calculate the sum of the interior angles of polygons. In other words, I want to know what the sum of all the angles in the polygon are. Now, we already know that for a triangle, that sum is 180. So let's look at this. Let's go ahead and put that down. 180 degrees. That's for a triangle. Now notice what I've done here is with this triangle, with this one right here, I've just copied it and used it to make a quadrilateral. Okay. So notice I've got four sides here, but still the sum of the angles for this one, it's going to be 180. And then for this one, it's 180. Because really, this is just two triangles in there. So in other words, this is 2 times 180. Okay? So 3 sides was 180 degrees. Now we're seeing 4 sides. Really, I could put another triangles together and I would get 2 times 180. Let's look at this next one, a pentagon. Okay, this one right here. Now notice what I've done is I've just connected some vertices and made 3 triangles. So notice here's 1, 2, 3 triangles. Each one of them have a total sum of measure of 180. So this pentagon here is 3 times 180. Okay, now let's look over here. We got 1, 2, 3, 4, 5, 6. Okay, so hexagon. And I did the same game here. I joined some vertices and made some triangles. I've got 1, 2, 3, 4 triangles. So each one of those has a sum of angles of 180. So we have 4 times 180. Now, look at this. We're talking about these polygons. And let's suppose that, first of all, let's just see if we can do a little bit of analysis here. When we had 3 sides, it was 1 times 180. When we had 4 sides, it was 2 times 180. 5 sides, 3 times 180. 6, 4 times 180. It looks like what's happening here is the number of sides is diminished by 2. So, and multiplied by 180. So, for example, let's suppose we have an n-gon. Well, this then looks like, keeping up with the pattern here, this would be n minus 2 times 180. And that would be the total sum of angles in the polygon. In other words, when we say the total sum of angles, think about this triangle. This angle, and this angle. And this one over here, we've got 4. This one, and this one. This line here, that's just part of the triangle. Okay. Now for this one over here, we've got this angle, this angle, this angle, this angle, and this angle, and those add up. Okay. So we're looking at the sum. For this other one over here, I can go ahead and show you this one, this one, this one, this one, this one, and this one. Those are the angles that we add together to get this sum that we're looking for. Those are the interior angles. Now, notice up here, they went ahead and gave us a theorem. They said the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. So remember, we're talking about a convex n-gon, a convex polygon. Okay, so let's see how we might apply that. Let's suppose we want to, in this problem down here, we wanted to find out what x is. Well, let's see how many sides we got. We got 1, 2, 3, 4, 5, 6. 6 sides. So this is going to be 6 minus 2 times 180. That's the sum of all the angles in there. Now that's going to be 4 times 180. Okay, that's the sum of all those angles. Okay, so we know that the sum of all those angles is 720 degrees. 4 times 180. Now, let's see what we've got. We've got here 88 plus 142 plus 105 plus 136 plus another 136 plus x, and that has to equal 720. Okay, so look what I've got. I've got 88, 142, 105, 136, 136, and x. So I just simply, just a simple algebra problem, and we'll find out what x is. And when we add these up, it looks like we get 607 plus x is equal to 720. And then I subtract 607 from 720, and I get, let's see here, 607, I get 113. Okay. So it looks like x is equal to 113. Okay, so that's how we use that. Now, look, if you're dealing with a regular n-gon, then you know that all those interior angles are the same. So if you want to find out what the measure of one angle is, you just divide. For example, let's suppose we've got a equilateral triangle. Okay, suppose we have an equilateral triangle, and we want to know what is the measure of one of those angles. Well, we would say 180 divided by 3, and we would get 60. That's for an equilateral triangle. Now, if we had a pentagon, we would calculate for a pentagon. Let's look at this. A regular pentagon. Okay, let's suppose we have a regular pentagon. Then we would say, okay, the total number, the total sum of the angles is 5 minus 2 times 180. Times 180. And we want to divide that by the number of angles, which there are 5 in there. So this is going to be 3 times 180 over 5. And that will give us, let's see here, 5 will go into 180 36 times. So this will be 3 times 36. And that will give us 3 times 36 is 108. Okay? So each measure, each angle in a pentagon would be 108 degrees. A regular pentagon, that is. That's what we have to remember. Okay. Now, realize what we're talking about here is these angles in the interior. Now, you can remember if you've got a polygon, you can extend the sides out and get exterior angles. So, for example, look at this one. We extended this side out and got this angle. Okay? We extended this side out and got this angle. If we extend these sides out, we get these exterior angles. Now, the question is, well, what is the sum of the measures of those exterior angles? Now, I want to look at just a quadrilateral. And notice of course we're dealing with convex polygon. In this whole discussion here, it's all convex polygons. Notice that I've made my exterior angles. So we're looking at this little quadrilateral. And I made a circle over here. I'm going to take this angle 2, and I'm going to plot it right over here, okay? So this is angle 2, okay? I just kind of copied it over. Angle 3, copy it over here. There's angle 3. Angle 4. And then angle 1 is right there. See? See, all I did was I just took these angles and just kind of moved them over and put them in the center of a circle. Now, let's see what we've got here. Let's see what we've got. These make central angles. And you notice they go all the way around the circle. Okay? So this one's 90 degrees, this one's 90 degrees. Every one of them is 90 degrees. 90 degrees. And in this case, for the quadrilateral, and notice you're going to get 360 degrees because they just make a circle is what they make, right? Now, things wouldn't change really if we weren't dealing with a quadrilateral. Let's suppose we were dealing with a pentagon like this. Well, I would do the same thing. I would take this angle, move it down, have the, at the center of a circle, put this angle with it, this angle, this angle, this angle. But still, it's going to make a complete circle. So it's going to be 360 degrees. So here's the thing. The sum of the measures of the exterior angles of a convex polygon is going to be 360. And we're talking about one angle at each vertex. In other words, you could get another angle down here, extending this way. We're talking about when you get these exterior angles, you get a couple of them. We're picking one for each vertex. The sum of those angles is going to be 360 degrees. Now, if the polygon is regular and you want to know, well, what is the measure of one of those exterior angles? Just take the 360 and divide by the number of sides of the polygon. If it's a pentagon, it would be 360 divided by 5. Okay, so let's take a look here. Let's see if we can figure something out, or if we can use that to solve a couple of problems here. Find the value of x in the diagram, okay? So here we go. We have this. We have these exterior angles. We have 2x plus 2 more x. See, just writing these. Plus x plus 3x plus 4x. And we know that this has to equal 360 degrees. I'll just put 360. I'm leaving off the degrees. Now that looks like it's going to be 12x equals 360. If we do a quick adding up there, and then divide by 12, and we get x equals 30. Yeah, that's it. So x equals 30. But the key idea there was that the sum of those exterior angles add up to 360. Okay, now let's look at this next one. This next one over here. Here we want to figure out what x is. Now, x is an exterior angle, and this happens to be a regular, I don't know, how many sides is it? 1, 2, 3, 4, 5, 6, 7. Okay, so it's got 7 sides. So x is going to be equal to 360 divided by 7. Yeah, that's it. So those are the concepts that this whole section here is just interior and exterior angles.